Hello students, welcome back to Organic Canvas. In this video, I'm going to teach you how to convert the given reactant to product by using 5 reagents out of 15 reagents given over here. What we are doing to the reactant, just observe, we are going to introduce a halogen at this primary carbon. This we cannot do in one step because whenever you do the halogenation for the given reactant, it mostly goes to this particular carbon. That means what? We need to do it in multiple steps, and also we need to use proper reagents. For that, you can guess what reagents we might have to use in the beginning and you can eliminate the other options. Say, for example, we'll not do ozonolysis because the number of carbons will remain same, right? And also, we might not have to use the sodium borohydride, right? So like this, you can eliminate some of the reagents. But what we might use is bromine in sunlight or HBr in peroxide or maybe sodium ethoxide because we have to introduce a halogen and then do the dehydrohalogenation. So these are the common reagents we are going to use. So let's get started. Whenever we have this molecule, right, an alkane, it's not so reactive. Therefore, in order to do the halogenation of this, we use bromine in sunlight, which will follow a free radical mechanism. Although we have different type of hydrogens, say here and here and here, right? So the reaction can happen either here or even here. How do you decide? See, because it's a free radical mechanism, the formed free radical should be stable. And we know that a tertiary free radical is more stable. That means what? We are going to replace this hydrogen, tertiary hydrogen, right? So we are going to get this as a major product. The bromine is going to the tertiary carbon like this. Now, students also remember what reagent we are using. You can note that number because ultimately we have to solve for this particular solution, the equation, right? So that's the reason. So bromine in sunlight, so this is 2. So that's nothing but P. I'll write that also. Okay, so now we have to get rid of this bromine so that the double bond will be formed here and then form a double bond here and then maybe you can introduce the bromine on this carbon. So that is our ultimate product, right? So now how to remove bromine? So sodium hydroxide or maybe any base. So let's check a certain base. Say here this is a sodium ethoxide, which is a base used for dehydrohalogenation. So we can use this reagent. So this will be Q, that is nothing but 7. So what ethoxide does? Ethanol is a solvent, so heating condition. So it will remove hydrogen either here or here or here. Doesn't matter because it's a symmetrical molecule, right? So dehydrohalogenation, right? And then you're going to get the double bond over here. So we almost getting closer to the carbon, this carbon, right? So let's do the hydrohalogenation of this double bond. So, and also make sure that the bromine will be somewhere here. So that means what? It should obey anti-Markovnikov's hydrohalogenation. And what is the right reagent? So this one, because of the peroxide. So that will be R and R will be 5, right? So that is nothing but HBr in peroxide, anti-Markovnikov's rule. So according to anti-Markovnikov's rule, what product are we going to get here? So the bromine will be here like this, right? So now PQR is done. Now let's check for S. What is S here? Of course, we have to do the dehydrohalogenation, and for that we need a base. Which base are we going to use here? Let's use tertiary butoxide. This will help us to remove the proton from less sterically hindered side. So here, it will not remove from here because of the steric hindrance due to these groups. Steric hindrance means this place is kind of blocked due to the bulkier groups. Now, The tertiary butoxide, right? It's a bulky group. What it does, it will take hydrogen from less sterically hindered. Again, you're doing dehydrohalogenation. And how do you write the product? Like this. Yeah, so we are almost there. Now, let's write down the number also. The tertiary butoxide is 12. So, 12. Ultimately, we have to again add the halogen. So, for that, what we will do? Again, let's use the same HBr peroxide. So, T is again HBr in tertiary butoxide. Sorry, the peroxide, right? So, the peroxide in sunlight, right? Yeah. Then what happens? The bromine will go here. And just check. Yes, this is a final product. But let's solve for the value. P is 2, Q is 7, R is 5, S is 12, and T is 5. So 5, 5, 5, 10, 17, 19 minus 12 would be 7. So 7 is the final answer. And where do we have it? In option B. Therefore, the right option is B. If you would have found out any other method for this particular conversion, you can comment it in the comment section. Thank you for watching this video.